Hello students, welcome to Learn Vectors. So our today's topic is electromagnetic induction, right? It is very interesting topic in which we will find out the value of induced current, right? How current are induced in the circuit. For now, we have studied about magnetic field, the properties of magnetic field, right? At some distance, or you can say inside the cylinder, inside solenoid, outside the solenoid, what are the magnetic fields. But now we will find out how do we induce current in the circuit, right? Methods to induce current in the circuit, or you can say potential difference. We are all aware of AC generators, right? We will also introduce the concept of AC, that how the AC currents that we use in our daily life, how do we generate that? We generate it using the concept of electromagnetic induction only, right? And also we will talk about transformers. So to know how to induce such currents, there were some observations made, right? So we'll discuss those observations. So our first observation was something like this. So let's say there was some magnetic field which is going downward to the plane, which is denoted as cross. And if we will put some loop, let's say radius of loop is r, and if we'll put that loop inside that particular magnetic field, now what will happen if we will change the magnetic field? First of all, the magnetic field is constant and we have kept the loop inside the magnetic field. So it was observed that there was no change in the system. There was no current in that particular loop. We have introduced that loop inside the magnetic field just to induce the current. But here I am not changing anything in the system, so current is not there in the loop. But if I am changing the value of magnetic field, let's say I am changing the value of magnetic field, or you can say increasing or decreasing the value of magnetic field. So it was observed that by changing the value of magnetic field, there was some current induced in the loop. So there was a question, how that current is induced there? I didn't do anything. I just changed the value of magnetic field in which the loop was kept. Either I am decreasing it or either I am increasing it, right? Somehow I am changing the value of magnetic field, and I have observed that there was some current in that loop. That means that current came from somewhere, or you can say that that current was induced, right? And that current, we will say it as induced current, right? So our first observation was that if we will change the magnetic field, there was some current that we have observed. We will see that how much current will be there, how much current will be induced, that we will see later. But for now, our observation was that if we will change the value of magnetic field, we realize that there was some current in the loop. Now our second observation, right? Now what I am doing is I have kept the same loop of radius r in some magnetic field. Now I am not changing the magnetic field, I am not changing anything. Still you can say that current is 0 if I am not changing anything. But somehow I am just changing the radius of that particular loop, right? So what do I mean by changing the radius of particular loop? That means, let's say I am expanding the loop, I am increasing the radius of loop. That means I am increasing the area of loop, right? So if I am increasing the area of loop, it was still observed that there was some current induced in the loop, right? From where this current is coming from, right? That current is known as induced current, right? So our first observation, in our first observation, we have seen that whenever we will change the value of magnetic field, the loop which is kept in that magnetic field, that will have some induced current, right? And our second observation was that when we change the area of that particular loop, or you can say radius of that particular loop, radius means area, right? So at that time also we have observed that we found some current, and that was induced in that particular loop. Now our third observation, we kept the same loop in the magnetic field, right? We kept the same loop in the magnetic field, and I have started rotating it, right? So I have started rotating it. I am not changing the radius now, I am not changing the value of magnetic field now, but what I am doing, I am just rotating that loop, you can say along this axis, right? So if I am rotating this loop about this axis, this loop will rotate, but it was still observed that there was no change in the current. That means there was still zero current, right? Initially it was zero current, but when I start rotating it with some angular velocity omega, there was still zero current. We didn't observe any kind of current. But in this case, right, in the fourth observation, it was observed that if I am rotating about this axis, right, not that this axis, if I am rotating about this axis, so the loop will rotate something like this, right? So if you will observe this particular loop, you will see that if I am just rotating this loop like this, what is happening here? Here the angle between that particular magnetic field, right, magnetic field was, you can say, downward, which is cross, which is denoted as cross, and the area of the loop is outward or inward, you can say, right? Because for open surfaces, we can consider that area is perpendicular to the surface, either they can be outer side or inward. So here, as you can see that if I am changing the angle like this, if I was changing like this, there was no change in the angle between B and A. B and A means magnetic field and area, right? Here the magnetic field was inside and area was outside, or you can say, let's say, inside, right? So there was no change in the angle between magnetic field and area, but in this case, whenever I am rotating it about this axis, it will go like this. So there is a change in the angle between B and A. That means angle between magnetic field and area is changing now. So in that particular case, it was observed that there was some current induced in the loop, right? So we have our such four observations that whenever we are changing the value of magnetic field, the loop which is kept inside that particular magnetic field, it has some induced current, right? Now in the second case, what we have done, we have increased the area or decreased the area, right? That depends upon us, but the point is we are changing the area. By changing the area, as we can say that there was some current induced in the loop. And in the third case, when we are not changing we are rotating, but we are not changing the angle between B and A, right? Still there is no current in the loop, but in the final case, I am changing the angle between B and A, and now I am observing that there is some current in the loop, right? So combining all these observation, we will understand that why this current is, you can say, inducing, why this current is induced, right? So there were some observations. So first observation is by changing the value of B, the current will be induced. Our second observation is by changing the area of the loop, our current will induce. And our third observation is by changing the value of angle between B and A, our current will induce, right? So these are three observations that we made.